student. Today we are doing chapter number 5, complex number and quadratic equations. So all of you, what is a complex number? So any number written as a form of a plus iota b. It is generally represented by z. Z is equal to a plus iota b. Is it? We can write. We have to write complex number like this. In this, a is its real part. It means you can write real z is a and imaginary part is b, so imaginary z is b. So you are thinking about the iota. What is the iota? So value of iota is under root minus 1. So when we are doing squaring both sides, so I squared is equal to minus 1, and when we are finding I cube, so we can write it like I square into iota, so minus 1 into iota, so I cube is minus 1. And if we want to find I to the power 4, so we can write iota square into iota square minus 1 to minus 1. So we know iota to the power 4 is 1. We can use this observation. We can use this observation in many ways. Like if we have iota to the power 4, it should be iota to the power 4 is minus 1. If we have iota to the 12, so we can write it iota to the power 4 into 3. We can write iota to the power 4 here, whole power 3. So 1 to the power 3 is 1. Iota to the power 100, how we have to write iota to the power 25 into 4, so iota to the power 4 whole power 25, so its value will come 1. So this is the values of iota and all. Now what is the conjugate of a complex number? Like we have a complex number z is equal to a plus iota b, so its conjugate will be z bar is equal to a minus iota b. It means you have to change the sign of its imaginary part and you will get the conjugate. Now what is the modulus? How we have to find modulus of a complex number? If you have z is equal to iota b, then its modulus will represent by z bar, so it will come under root a square plus b square, means under root real part square plus under root plus imaginary part square. Now some difference in product of a complex number, like we have a two complex numbers z1 and z2, and we will add this, so real part will be added in real part and imaginary part will added in imaginary part. And also in its difference, the real part will subtract from real part and imaginary part will subtract from imaginary part. And its multiplication, you have to multiply every part with same as we done multiplication in simple observation, all of you. Now modulus representation in graph. Let a point p represent, this is a point p represent a complex number z is equal to x plus iota y in the complex plane, then the length OP is called the modulus of complex number z and is denoted by z bar. This OP, and it may be find like OP is equal to under root x square plus y square. The angle XOP is called the amplitude or argument of z and is written as amplitude z or argument. The value of amplitude z satisfying minus pi less equal to theta less equal to pi is called principal value. It means value between these two will be principal value. And now what is the polar form of a complex number? So let we have a number z is equal to a plus iota b, so it may be represented like this on complex plane. Now let OP is r, so if this is theta, so cos theta will be base upon hypotenuse, so a upon r, so a is equal to r cos theta. Sin theta is equal to b upon r, so it will be r sin theta. B is equal to r sin theta. Squaring the and adding the both sides, r square cos square theta plus r square sin square is equal to a square plus b square. Then we will find r is equal to under root a square plus b square. This is its mod. Now we will divide equation 2 by equation 1. So r sin theta upon r cos theta is equal to b upon a, so tan theta is equal to b upon a, theta is equal to tan inverse b upon a. So the polar form is equal to r cos theta plus eta sin theta is called the polar form. Now solution of quadratic equation. If a quadratic equation of the form have its discriminant less than 0, so we will find its values by this formula: x equal to minus b minus under root minus 4 ac square 4 square minus b square into iota upon 2a, where b square minus 4c is its discriminant. So this is the introduction of complex number. Thank you very much.